All right, second part. I wanted you guys to feel a little guilty. Look how yummy that lunch is, and I can't eat it because I'm doing this video. Feel bad? Hope so. All right, that's for you, Ahern. Here we go. Determine the component form for the following. A vector with magnitude 6. That's just telling you the spinner is 6 units long, and that's telling you the direction's 150. So we go like that. Boom, 90. Now we go 60 more, which is right there. And there she is. Isn't she a beauty? 6. What's the component form? Well, it's saying find the x and find the y. And put it in this sort of looking thing. Well, if that's 150 making this 60, that means this is 30. So we take half of the hypotenuse and we get that to be 3, and we multiply that by the square root of 3, so that's 3 square root of 3, but it's negative, which is huge. So it's negative 3 square root of 3, 3. There's the component form of that story. How about this one? Magnitude 12, 315. It just means take your spinner, which is 12 units long, go 315, which is right there. Sorry about that little bend. Oh, okay. Not even on the video. There you go. So 315, this is 12. That leaves us with a 45-degree angle. Here comes the component form. I'm taking that 12 off. That was the original length of the spinner. Now we've got a 45, 45, 90, and we know the hypotenuse is 12. So how do we get back? We divide by the square root of 2. So let's get that out of there. So we get 6 square root of 2 and negative 6 square root of 2. And so there's our component form. 6 square root of 2, negative 6 square root of 2. There she is. All right. I need to get a nice picture of this before we get cooking, so give me a second. I might have a bite of my chicken. Okay, so this problem has a lot jam-packed into it. I want to explain there's also a very high likelihood of a typo in this set of instructions, so let's just dive in. An airplane is flying on a course that's 40 degrees south of west. So here's west, south. So 40 degrees south of west means you go south, down from west. That's what it means in pilot aviation talk. 320 miles per hour, that's how fast the plane's flying, and that's your magnitude. So that's the direction and force. So here we go. That's pretty simple. It says if the jet experiences a headwind, now here's where the twist, the tongue twister, the brain twister comes, that is blowing 25 miles per hour due west. Due west, a headwind would mean right into his head, that way. But then it says due west, which actually means this way. And for the sake of math, I'm really about 99% certain that it's going to be due west and not a headwind but a tailwind kind of behind it. And here's why. So at that moment, and we don't know, it could be after an hour or 2 hours or 3 hours, they don't tell us that, but at some point in time, that wind from behind is another, this is a different like XY axis, placing this here, and now the magnitude of that is 25 miles per hour. That's a force upon that force. And now we're going to do some math because it says what's the resulting speed and the direction of the plane. So this is kind of interesting. The speed is simply telling us, and this could get really messy, to find this resulting vector. So if we can find the length of that thing, we found the speed. All right, so it should be more than 320 because we're getting a tailwind, and this is the triangle that it creates. And here we go. Well, here comes some interesting math. If this is 40, I'm looking at this triangle right here. We know this is 90. 90 plus 40, that's this, is 130. And so that would leave us with 50 degrees right here. And this we know is 90. See if that helps us at all. And let's keep on going here. So what we have here, and I'm going to put some labels here. I'm going to call that A, I'm going to call that B, I'm going to call that C. I'm going to peel that little drawing off so we can look at it a little bit better. Definitely not to scale. 25, 320, 90, and 50 adds up to 140. And so we've got this A, we've got this C, we've got this B. Notice we've got side A, we've got side B, we've got angle C. So the formula that allows us to use that is C squared equals A squared plus B squared minus 2AB cosine of angle C. And that's going to allow us to find C, and that's the whole point of this problem. But the language was awfully funky. I will give you that. C squared, let me fill this stuff in and not take up all this time. Okay, so as you can see, I plugged things in. A squared, boom, B squared, boom, A, boom, B, boom, multiply that all out, condense, 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 by taking the square root of both sides, and then you get 339.5. So 339.5 is the resulting speed. That's this right here. All right, now what's the direction? Well, this is going to be a little crazy. So let me get another drawing for you. I'll be right back. Okay, so instead of drawing another drawing, I just thought we'd use what we have. Remember, this originally was 40, so if we could figure out what this little slice is, which is this, we'll be able to subtract that from 40 and figure out what that is, and then add that to 180, and that would be our resulting direction of the plane. This is challenging. So we got to find angle B. Well, we could use the law of sine right now, because we're going to use sine of B all over side B equals sine of angle C all over side C, 339.5. And let me crunch some numbers and I'll be right back. Alright, so I looked this up and cross-multiplied and got this, cross-multiplied that way and got this. Now I'm going to divide both sides by 339.5, 339.5. I'll be right back. Okay, so divided that, got this. So then I went second sine, 0.047. The calculator spit out 2.7 degrees. So that little sliver right up here is 2.7. So if I subtract that from 40, I'd get 37.3. Hopefully I got that right. I think I did. But then I got to add that to 180, which would be 217.3 degrees. That's my 180. And then this would be my 37.3. And that found my direction of the plane. That is a doozy. Alright, so just in the event that what I chose to be wrong, like maybe the headwind was right, due west means coming out of the west. Here's the way you'd have to at least get started a little differently. So this is the same original drawing, but now you've got this situation where it might be coming this way at 25 opposite, and then your resulting vector would be here. And so this is 40, this is 90, this is 50, this is 90, so this is 40. And so now we've got this angle A, B, C, and we got this angle and these two sides. We could use the law of cosine again to find this, and that might be what they wanted us to find. It's just hard to navigate through the language of that problem. I just have to be honest with you. And then you'd have to find this angle using law of cosine, add it to 40, and then add that to 180 to find the direction. So it changes it depending on the interpretation of the problem. I'm not going to finish the problem for you. I just want to make sure you understand the principle. All right, here we go. Sine, cosine stuff. Write a possible equation. That means there's more than one. But when I look at things, I try to figure out is the initial side sine or cosine. I see cosine as the original because cosine goes over and then like this, and I can see that that guy has been flipped. Now what I'm going to try to do is consider that this is 4 below the x-axis, this is 2 above the x-axis. That's a total of 6 from bottom to top. That means the halfway I need to go down 3 or up 3. 1, 2, 3. So there's my midline, which is very important because that tells me a lot of information. Number 1, I know that it's been reflected, so I need to put a negative somewhere. I also know the amplitude is 3, so it's -3 cosine. Now because that hasn't moved to the right or left at all, there is no difference in B, so that's just going to be x, but I do need to find the period, and what I'm going to choose to do is go from here to here, and I can see that that takes, they do have the pi here, which means that's pi over 2, and this is pi over 2 to the right, this is pi over 2 to the left, so the entire period is pi. And I'm going to stick that into the formula. So period equals, there comes the formula, 2 pi over b, and I'm going to multiply this side by b, multiply that side by b, so I get pi b equals 2 pi, because these cancel, divide by pi, and I get b equals 2. So there's no shift right or left, so I'm not going to go x plus anything, I'm not going to go x minus anything, but I know b is 2. So -3 cosine, here comes the b, of 2x, and that's it, because it's just been flipped. Oh, my fault. It's actually been dropped down 1, so -1. And there you have it. All right, we're going to try the same thing here. Again, that's just one variation of different answers, but I'm going to stick with that one. This guy, because I used cosine this one, just for kicks and giggles, we use sine for this one. Now remember, the original goes through, so I'm going to pick a spot, which I'm going to pick right here, as this spot. And I noticed it's been moved. Well, maybe I better not move. Maybe I better not pick that one. Hold on a second. Because it's not like right on one of these little chunks, I could guess that it's halfway. Maybe I'll do that. I don't know if I want to do that. I think cosine is going to be a lot easier, you guys. So I'm going to stick with the cosine thing and go with it. That's still a half in a direction. So I'm going to stick with cosine. I'm sticking with it. All right, so if that's 2 pi, this is pi, which means this is pi over 2, which means if that's halfway, that's been bumped to the right, pi over 4. I'm going to start with that. So I know it's going to be x minus pi over 4 in my parentheses. I also know that it's been dropped down 2. You can see it's been dropped down 2, the whole thing. So it's going to be -2. And now the amplitude is 2, so I'm going to fill that in. 2 cosine x. And what have I not found? Okay, the period. So the period here, I'm going to go from, well, let's just go from here. And if we're assuming that that's halfway, this is pi, and this is 90 plus 45, 135. Sorry, I just converted into degrees. And that means this is 180 plus 45, which is 225. Let me pause a second. Well, let's figure that out. 225 minus 1, that's a negative, by the way. So here we go. Clear. 225 plus 135. So 360 is my entire period right there. And That's just 2 pi, which is normal, which is nice because that means that's 1. I'm going to take that x out of there. There's double x's there. All right, so they made that part of the problem easy, but it took a while for us to find out that it was easy. And because I'm in a hurry, little things don't pop out at me right away. It's definitely been flipped. And so that's been bumped right 1, plus it's also been flipped over. So there needs to be a negative there. Because remember, the general rule for cosine is it goes over in a positive direction. And this, if we slid that over, it'd be going under. So it's been flipped. That's my whole point. Okay, these two should be a little easier. It just says identify the amplitude. Well, it's right there. Amplitude is 2. Remember, the formula is the absolute value of A, but it's just that number. If it's negative, then you make it positive. All right, the period, because B is 1, is just going to be the normal period. Remember, the formula is 2 pi all over B. Well, if B is 1, then you just get the normal period of 2 pi. Horizontal shift, we're going to go right, pi over 2, and then the vertical shift is going to be down 3. These are pretty, little simple. It says graph 1 cycle. Shouldn't be bad. So there's pi, there's negative pi. Typical sine goes like this. And now we're going to just follow the instructions. We're going to double the amplitude, so it goes up here. And then it goes down to here. Sorry, not perfect. And then we're going to bump that right, pi over 2. So this slides to here, that slides to here, that slides to here, that to here, that to here, and so there she is. And last but not least, I need to drop that whole thing down 3. So this is down 2 already, so oh boy, it's a little below 2, sorry about that. So if I go down 1, 2, 3 more, and then 1, 2 there, and then this guy comes down 3. That should be down 1 more. That's terrible, you guys. So that point should be down here, just like that. That's up 2, so it should be here, and then that should drop down to here. There. I tried. That's not perfect. Here we go. We'll do this last one and that'll be it for this video. So, amplitude, that's actually a negative 1. So if you take the absolute value of that, that's 1. That's the amplitude. This is B. So if B is pi over 4 and I stick it into that formula right here, I get 2 pi all over pi over 4. I'm going to flip by the, or multiply by the reciprocal. These pi's cancel, and I get 2 times 4 is 8. Don't forget that's 8 radians. Tuck that away. And then that just simply means we need to go to the right 3 radians as well. So, what I might do in this situation is just go 1, 2, 3, 4. You know what? I'm going to stick with what I typically do. It just makes more sense to me. Some of you don't like it this way. Some of you would just use radians, and that's fine. My brain just works a little bit better this way. Negative 3 pi over 2 and negative 2 pi. Okay, so my entire period is 8 radians. 8 times 60 is 480. That means I got 240 this way and 240 that way. Keep that in mind. So let's start with cosine. The normal cosine would look like this. Right there. We do need to flip it, so that would go here, and then we'd end up like that. So I'm going to make that a little darker so it stands out. Now we got to really take care of some things. So I need to stretch that out so it's 240 to the left, so that's 270, that's 180. 180 plus 60, which is 2/3 of 90, would be right about there. And then the other way is about the same. I'm going to go with orange. So So it stretches it out just a smidge, not a ton, just a little. Okay. Because normally it's 180 to both sides, and these are tight little windows. Okay, and now the final thing I need to do is move that thing right 3. Well, 3 is 180-ish, which means 2 chunks. So the grand finale, I need to move this guy approximately 2 chunks. So 1, 2, right about there, and 1, 2, right about there, and this 1, 2, right about there. And right there. Pretty close. That finishes video number 2.